Hi, everyone. Welcome to the last of two lectures for the air pollution unit. We'll get to what that last lecture is all about in a minute. So let's go ahead and jump in to remind you about your exam date and how we're going to really focus all of our discussion about air pollution and the review that we're doing going forward on your two FRQs, where you design an investigation and analyze a problem and propose a solution. You'll notice that the first couple prompts here are the same. You guys are going to do so well on this. It's what we've been practicing every year or throughout the entire year. So indoor air pollution, it's actually a greater threat than outdoor pollution is. In terms of human health, obviously we don't have ecosystem impacts here, but those air pollutants get trapped in high concentration inside, and we get a high dose or exposure of them. Women and children in less developed countries are really at great risk because they spend a lot of their time working over an indoor or a poorly vented stove that might burn wood or charcoal or dung or coal. And normally our respiratory system acts as a pretty good defense mechanism. If you look at all of these strategies we have to prevent things from entering our respiratory system. And remember, our respiratory system, that we oxygenate our blood. So there's cardiovascular implications when things get deep inside our lungs, especially solid particulates. So even if things get past our initial defense system, we often will sneeze or cough them out. We're going to kind of focus first of all on a solid particulate indoor air pollutant. Pollutants, you may recognize asbestos from the class action lawsuits by James Sokolov. Asbestos is a fibrous, naturally occurring fibrous material that was used to insulate things. Like we would wrap it around pipes, and we put it in insulation under floors in buildings decades ago. Dust, ash, smoke, all of these things can get deep inside my lungs. And as I said, they can then enter my bloodstream and cause these cardiovascular problems. So when we think about the size of those kinds of things, we've mentioned particulates already as an outdoor air pollutant, that fine particulate matter. So this can be a dust particle, it can be pollen, it can be mold. I can zoom in a little bit more as to what's going on over here. For some of these things, we can have finer particles like wood smoke particles or fly ash. And not that I don't think this is specifically mentioned as a learning target in our curriculum, but it's rather pertinent. If we zoom in a little bit further, we can see the size of different bacteria and viral particles. Viral particles are tiny, 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 which is why it's so hard to block them with just kind of a normal, even respiratory mask. So these are all solid types of particulates. And if you look at the human health impacts, which is something they might ask me on an FRQ, we want to be able to talk about how they will increase the severity of respiratory problems like asthma. And if you can have that kind of generic statement, you're going to be in pretty good shape for describing a human health impact. The other big class of indoor air pollutants, not solids, but actual gases, are what we call VOCs, or volatile organic chemicals. Remember, we saw VOCs in the outdoor air pollution as well. They were an essential component of making that soup, that photochemical smog, the ozone part of that. And these are kind of scary because we are exposed to thousands of organic compounds, and by their nature, they are nonpolar and have really weak intermolecular forces. So they will very readily volatilize or go from the solid or gas liquid state to the gaseous state. And what you have to remember is anytime I put something in the air, I am constantly breathing air. It's not like a heavy metal where I might be exposed through my water supply and I can, like lead pipes, and I can just say, oh, I have to buy bottled water until they replace my lead pipes. If if there is something that puts that substance in the air, it's really hard for me to avoid breathing that air pollutant. So these VOCs can be everything from things that I spray in the air, um, chemicals that I use for cleaning. And you can tell that sometimes when you clean, you're like, oh, there's a really strong odor that gave off. That's because the organic compounds in that liquid cleaning product are volatilizing. They're going into the vapor or gaseous form, and I can get really high dose or concentration or exposure to them then. Um, Other indoor air pollutants, think the other big gaseous indoor air pollutants, to be clear, these are man-made chemicals. The other big indoor air pollutant that we want to worry about is this naturally occurring gas called radon. It's radon 222. It's a naturally occurring byproduct of the natural decay of uranium. And you remember, uranium is a metal that occurs in the ground. So it's kind of random if might have radon exposure in my home or not. I can have two people that live in the same general vicinity, and one person might have a big problem with radon in their home and the other not. So what happens is that radon gas is emitted from the bedrock during the natural decay of this naturally occurring uranium, and it seeps up through cracks in the rock, and it can enter my home. And many of you might have some of you may have a radon gas detector. Oftentimes, if you're going to buy a new home, people will want to do a test for radon gas, because if you determine that you have it, it's kind of hard to get rid of it. I have to figure out a way almost to vent it from my home. People that have radon gas problems maybe can't have any bedrooms in the basement, because that gas is going to accumulate and be in largest concentration in the basement. And so often what they have to do to mitigate the problem, if I just randomly have bedrock that's emitting this radon, is I have to have some kind of pump that's circulating the air in my home and constantly sucking that air out and putting fresh air in. So the last topic that we'll look at here are some of the solutions. Remember, one of those big FRQs focuses completely on solutions, and air pollution is often rather heavily assessed. We have 7 units of content, 2 questions. There's a pretty good likelihood you might see something about air pollution. So we're going to focus on the big categories for reducing air pollution control devices, regulatory practices, like the Clean Air Act, conservation, and alternative fuels, just preventing those things from ever getting in the air to begin with. So the first thing we want to reduce the amount of is carbon monoxide. Remember, nose clamp, that's one of the 6 criterion pollutants that we identified in the 1970s was causing big problems. And we've largely, you look at how the amount of carbon monoxide emissions have plummeted. It's because we required or legislated the addition of a catalytic converter to a vehicle. And what that catalytic converter does in an internal combustion engine, in a car engine, unless it's an electric vehicle where I'm burning gasoline, a hydrocarbon, is it takes and converts some of those, like carbon monoxide, NOx, and hydrocarbons, into less harmful substances. Now remember, carbon dioxide doesn't have any direct human health impact of me breathing it. Nitrogen and oxygen and gas are natural gases in the atmosphere. Water vapor is a greenhouse gas, but when you watch the last video on greenhouse gases, you'll see that water vapor just falls as precipitation very quickly, so we don't worry about it. So as part of our attempt to reduce emissions of this, we required or regulated that new vehicles built after a certain point had a catalytic converter installed. To reduce SOx emissions, nose clap, that's the S in SOx. The solution is simply to not burn coal. Now remember, If I provide a solution on an FRQ, I can't just ban something, or because then it's like, oh, just don't use electricity. I can say instead, I can replace my coal burning plant with a solar array field or wind turbine field or something that doesn't create the SOx emissions from the burning of coal to begin with. If I do burn coal, which we're probably stuck with for a while because we have a lot of it and it's really cheap and it's easy to get, I can install this air pollution control device called a scrubber, or often a wet scrubber. If you remember when we did the waste to energy incineration, when we looked at waste management, and you watched that short video and we saw that a big, huge part of the footprint of that plant was actually getting rid of the harmful emissions so that people didn't have a problem with incinerating waste. And how basically a wet scrubber works, I'm going to kind of describe it as it's going through this little animation here. Sulfur and nitrogen oxides are what we call acid gases, because as you know, they can react with water vapor and form acid rain. So that gas comes into this big scrubbing system, and I'm spraying a mist. You can see that dark, that kind of orangish yellow NOx gas. I'm spraying this mist of a basic solution, like a calcium carbonate solution. And for the most part, what happens is I create a solid precipitate from that gas reacting with that liquid. I precipitate out a solid that I then collect and can send to a landfill. And they're not going to ask you a lot about how this works, I don't think, as long as you can simply identify that using a wet scrubber is a really good solution for removing SOx. In terms of removing particulates, that's the pee and nose clip. I can use an electrostatic precipitator. Again, I don't think you're going to have to describe in a lot of detail how they work, but if you think of all that ash and fly and the particulates that we've looked at, they have a little bit of a charge to them. So in an electrostatic precipitator, my charged smoke particles get sucked onto an oppositely charged electrode within this big device. And then all of that solid particulate is collected as solid and taken to a landfill. So a couple quick questions. Oh, shoot, weren't supposed to see the answer there right away. Well, you can go back and look at that one later. Let's just do a quick matching here. To make sure you can identify an impact of each of these different pollutants. So I'm going to give you just a second to look at that and I'll show you the answers. Natural gas emitted from uranium, just went over that one. Formed by incomplete combustion of hydrocarbons. We talked about this earlier, but I just went over a way to mitigate the amount of that. Primary pollutant formed from the combustion of gasoline. This one should be easy, a heavy metal emitted from the combustion of coal. A secondary pollutant that is a harmful component of photochemical smog. A greenhouse gas from burning fossil fuels with no direct human health impact. And a VOC emitted from fabric and foam insulation is formaldehyde. The last lecture that you're going to watch is one of the College Board lectures that I've already done on climate change and greenhouse gases. And I'm going to have you watch that one, and then you're going to be good to go. I will post the summative exam and the FRQ. There's a practice FRQ already posted. So you have 3 things that you have to turn in for the air pollution unit: a practice FRQ, a summative FRQ, and a relatively short, I think there'll only be about 20 questions on the summative multiple choice exam. Make sure to shoot me an email if you have any questions. See you guys. Good luck. Take care.